guys, and welcome to today's tutorial video. My name is Henna Morkel and I'm the UAV and drone specialist and pilot for Optron down here in South Africa. In today's tutorial video I would like to show you how easy it is to connect your SenseFly fixed wing eBee-X drone with your computer, connect it through the internet to a VRS or virtual reference station network, or in some countries also called a CORS network, which stands for Continuously Operating Reference Stations. Now, why would we want to do that? Well, if you are connected to a virtual reference station, your drone in the sky basically becomes a rover. So each and every photo that it takes in the sky will be already within a 2 to 3 centimeter X, Y and Z positional accuracy of where it should be in the real world. It is important to note that by using a VRS you will have to be within a 30-kilometer radius of where this base station or CORS network station is situated. Because if you go beyond 30 kilometers, you will start to lose accuracy. It is also important to note that while using a VRS system, which lets your drone fly and take each image within 2 to 3 centimeters in positional accuracy in X, Y and Z, this does not mean that you do not need any ground control points for your survey. It is still recommended, based on photogrammetry principles, to have a couple of ground control points throughout in your survey area, spread evenly throughout your survey area of interest. 5 ground control points at least, 1 in each corner of the survey and 1 in the middle is recommended. Another point is, by using a VRS system with your drone, it greatly reduces the amount of time that you have to spend in the field, as your images are already captured with a high degree of accuracy, because the VRS station is sending the correction of the positional correction of the drone to the drone while it is flying, and the photo gets a correction, GPS correction of the station of every photo that it takes. Alright, so with that being said, let's get into it. So firstly I'm going to unbox my eBee-X drone and assemble it. I take out my main body of the drone, one battery and my USB ground modem, which talks to the computer, and its cable. Now I take out the left and the right wing respectively for the drone, and I can place this tray back in the box. Now I'm going to attach the wings of the drone, making sure that the connection at the servos are correct. You will hear a clicking sound. Make sure the wing is attached correctly. The left wing. So here you can see my eBee-X drone. The payload is already camera is already inserted. This is the soda 3D camera. So it takes 3 images, not just downward, but one at a 45-degree angle, one at another, one straight down, and one at another 45-degree angle. This gives you high detail on the sides of building facades or high walls in mines. Now I'm going to connect my USB ground modem to my computer, which talks with my drone. You will see 3 blinking lights as it is the antenna is searching for the drone. Now I can go ahead and place battery inside, switching the drone on. So you see here the battery compartment with its Velcro strap. I simply insert the battery . The drone will go on. You'll hear the servos and you'll see the blue light. Now I'm just fixing up the strap so that it will keep my battery safely harnessed in the battery compartment. Now I can go ahead and place my battery compartment bay back and let it click nicely. The drone will now be looking for satellites, as you can see from the blue light here. And from the USB ground modem, you will see all 3 lights are now solid red, which means the antenna is seeing the drone's antenna. Now we're in the position to go and connect to our drone in the eMotion flight planning software. Now that we've successfully assembled the drone and it's connected with our radio modem with the computer, we can now go ahead and open up the eMotion advanced flight planning software. In the eMotion flight planning software, I can go ahead and create a new mission and name it accordingly. This mission I'm going to call VRS eBee-X test, and then I click on create mission. After I've created the mission, I can go ahead and connect to my drone on the left hand corner on the connect button that flashes. In the connection screen you will see the serial number of your eBee-X, and underneath the button called connect to your drone. Click on that.
Pre-flight checks completed.
So the drone went through a series of pre-flight checks where you'll see the pitot tube on the drone is still, or the status LED on the drone is still blue, flashing blue, showing you it's looking for satellites. In the flight eMotion screen we can see it has found 16 satellites. It still gives us at the top here indication RTK source not defined and the start and the home point not set. So thus this we can do in our flight planning. first go onto the Start, Takeoff and Landing tab. I can place my start. This is the first point that the drone will fly to after takeoff. And I place my landing. This is the point where the drone will come in for landing after the mission. You would normally want your start and landing point at the same location. Then I go onto my blocks tab. I create a new mission. I say add mission block, and I'm going to say 3D mapping because we're flying with the Soda 3D camera. And I place it on the map. It by default gives me a 9-hectare area, which I can then go and make bigger to cover the entire area of interest that I would like to fly. Then, now, here in the RTK source not defined, on the left hand, under the RTK PPK tab, you have to go and click, and where it says choose an RTK source, you click on the drop down menu. Over here you will see virtual reference stations. But first, let me show you where you set up the virtual stations. So if you go on to set up RTK PPK, and now you go here on the little globe where it says virtual references, here you will have to connect to the VRS or the CORS network in your respective country. Now what we have here in South Africa is called TrigNet. It is a national grid of strategically placed continuously GPS logging stations throughout the country. Over here in this virtual reference wizard, you have to enter the server IP address that you will get from the website, and the port, and your credentials, your username and password. Then it will give you all of the GPS reference stations for your country that you can go and add to your Emotion flight planning software. I have done this already as I am in Pretoria. I've done this for Pretoria. What you want to see is the RTCM.3.1 source correction that you can get. So you see over here there's a PRET, PRET-SB, which stands for single base, so it will be a single base line. So if I go back on to choose an RTK source, and I say PRET-SB, the Pretoria, you see it will connect here onto the VRS on the left hand side. The notification will go away, and then you'll see here in GNSS mode it starts to drop as the correction is being sent from the virtual base station. Now it's on 0.7. On the left you'll also see GPS OK, GLONASS OK, and the coordinates of the actual reference station. If I zoom out of my screen, if I know prior to where the GPS base station is, I can see here in my screen, I see there a little tripod with a GPS on it. This signifies where this base station is located. If I zoom out on my screen again and we make a measurement, if I measure from that base station to my area, you can see it's roughly 12.8 kilometers away, which is within our 30 kilometer acceptance range. Now if we zoom out again, you will see, if we go and look at the GNSS mode, we are now on RTK fixed, so it's giving us a 0.033 correction, meaning that your drone is now within 3.2 centimeter positionally corrected by the base station or the VRS base station, sending that correction to your drone. This was then the last step that we had to go through to set up the VRS correction, RTK correction with your drone, and we are now ready to conduct our flight in an RTK mode, which means each and every picture will be within that 3.2 or 3.5 centimeter accuracy range. So we are ready for taking off our drone. You will now see that the LED on the drone has turned from blue to green, signifying that we have GPS lock and we have enough satellites to fly the mission. So to launch your eBee-X drone, you simply shake it 3 times towards you. It has gyroscopic sensors in that will detect motion. Then the motors will start up gradually. Then you have to tilt the drone so you have the correct angle of attack to be launched into the sky. So you simply shake it 3 times towards you. It does its pre-flight checks. The motor will spin full up. After your drone has taken off, then it will proceed to the first flight line for conducting its flight mission. As you can see here, the drone is climbing. If you see on the square rectangular box on top of the drone picture, there it's 35 meters above takeoff. And it is now climbing up to the altitude of the mission. So while your drone is flying, you must just monitor its battery level, the link quality to the radio modem, as well as your RTK fixed GNSS accuracy of your images that will be taken. There you can see the drone is now turning and going on to its first flight line to take pictures. There you can see it take the first picture, the second picture, and so forth. This will proceed throughout the whole mission until the area of interest that you wanted to fly is flown. And the plus point of this whole exercise is so that all your imagery are within the RTK fixed accuracy, that the correction is being sent to your drone, to the photo in flight. Okay guys, this then concludes the tutorial video which I wanted to share with you, showing you how easy it is to connect your SenseFly fixed wing eBee-X drone to a VRS network in order to do successful RTK drone or UAV surveying and flying. Thank you for watching. Until next time. Cheers.